Hello everyone, I'm Landon Schlungen, and today we're going to learn Bash scripting by building 5 programs. Bash scripts combine terminal commands and logic into programs that can execute or automate tasks and much more. And it's a 220 lesson course, and we're going to create 5 small programs. So let's get started. Create a GitHub account if you don't have one, and let's start this course. We're probably going to use CodeRoad again. Yep, run with Code Ally. All right, here we have it open. The first thing we need to do is start the terminal. Do that by clicking the hamburger, or you can do Control Backtick, and that will open up the terminal for you. You should echo the correct, oh, I must have ran it accidentally. Once you open a new one, type echo hello bash into the terminal and press enter. So we can just type in echo hello bash, and then we're good to go. All right, and then Control enter to continue. I'm just going to do that every time so that I don't have to scroll down. All right, let's do these 220 challenges. You can run commands in the terminal or put them in a bash or put them in a file to be run as a script. You will be making 5 small programs to learn some scripting. The first one will be a questionnaire. Use the touch command to create questionnaire.sh. All right, touch questionnaire. Questionnaire.sh. I think I spelled that right. Yep. All right. To start, open the file in the main editor by clicking the file name in the left side panel, then add the text echo hello questionnaire at the top of the file. All right, so we're actually going to open up this file, and we need to add echo hello questionnaire at the top of the file. All right, so I think I can copy this. Hopefully copying and pasting works. Yes, it does. Okay. And then, oh, beautiful. It knew that I copied and pasted. All right. Your script has one command. Run it with sh questionnaire.sh to see what happens. All right. So type in here sh questionnaire. Can I tab over? Yes, I can. Hello questionnaire. So it ran whatever is in there. Sweet. All right, using sh to run your script uses the shell interpreter. Run your script again with bash questionnaire.sh to use the bash interpreter. All right, so we can do bash questionnaire.sh, and it goes hello questionnaire. Again, same thing. All right. The output was the same. There are many interpreters which may not give the output you expect. Find out where the bash interpreter is located by entering which bash in the terminal. All right, which bash? User bin bash. That's the absolute path to the bash interpreter. You can tell your program to use it by placing a shebang at the very top of the file like this. Add shebang at the very top, and it looks like this. Hashtag bang bin bash. All right, so let's add that because it's user bin bash, and we have to add it to the top of this file. All right, and yes, awesome. Okay. Now, instead of using sh or bash to run your script, you can just run it by executing the file, and it will default to bash. All right, and then we just have to type in the path of it. Questionnaire. Come on, are you kidding me? I can't tab over. Okay, whatever. Oh, dot slash. Questionnaire. Wait, what? Permission denied. Okay. You got a permission denied message because you don't have permissions to execute the script. List what's in the project folder in long list format with ls-l to see the file permissions. ls-l. Okay, cool. Next to your file is rwrr. All but the first character describe permissions different users have with the file. R means read, W means write, X means execute. I don't see an X anywhere, so nobody can execute it. Enter chmod plus X questionnaire.sh in the terminal to give everyone executable permissions. All right, let's actually close this quick. And let's run chmod plus X questionnaire.sh. Awesome. List what's in the folder again with ls-l. And there we go. We have some X permissions on there on the questionnaire.sh. All right, the X was added by each type of user to note that anyone can execute the file. Run your file again. All right, .questionnaire /questionnaire.sh. And there we go. It works. In your script, you can add any commands that you would be able to enter in the terminal. Test this by adding ls-l command below your other command. All right, ls-l, and there we go. Beautiful. Run the script again, execute it again. All right, click back into here, up arrow. Beautiful. All right, your script printed the result of the two commands if you entered them in the terminal. Delete everything but the shebang. And there we go. Okay, let's delete that. Should be good. Yep, awesome. Bash has variables, functions, and other things you might be familiar with. You can create a variable with variable name equals value. There cannot be any spaces around the equal sign. If a variable has any spaces in it, place double quotes around it. Create a variable named question1 and set its value to what's your name. Interesting. I haven't really worked with this shell language before, so this will be first for me. So let's do this. Question1 equals what's your name? What's your name? Right? That's what they want. Yeah, okay, awesome. To use a variable, place $sign in front of it like this. Shell scripts run from top to bottom, so you can only use variable below where it's created. Use echo to print your variable. All right, so we can just go echo underneath here, echo $sign question1, like so. Yeah, awesome. All right, run the file and see if it worked. All right, what's your name? Awesome. Question was printed. Next, you want to be able to accept input from a user. You can do that with read like this, read variable name. This will get user input and store it into a new variable. After you print the question, use read to get input and store it in a variable named name. All right, read variable name, store it in a variable named name. All right, so we can go read name. Okay, awesome. At the bottom of your script, use echo to print the hello name to the terminal. All right, echo hello $name. Name. I think that's what they want. Echo hello name. Run. Echo hello name. Use echo to print hello. Oh, I forgot a period. Oh, there we go. Awesome. Run the file again, type your name, and press enter after it asks for it. All right, let's do that. Go down here. What's your name? Landon. Hello, Landon. Hey, that's pretty cool. Right below your first variable, create another one named question2. Set the value to where are you from? All right, let's go question2 equals where are you from? Beautiful. After your read command, use your new variable to print the next question. All right, after my read command. After your read command. Um, I'm just gonna do echo question2, see if that works. $sign question2, and let's see if that works. Okay, whatever. Below where the second question is printed, use read to get input from the user into variable named location. All right, so we're gonna go location. Wait, no, read location. Here we go. Change the existing response to hello name from location. Hello, the existing response. This response? I'm just gonna go down here. I think they actually want something else. Hello, name from location. Hello, $sign name from $sign location. Period. Okay, yeah, that is what they want. Okay. Run the script and enter values when it is waiting for input. All right. All right, what's your name? Landon. Where are you from? Fargo. Hello, Landon from Fargo. All right, it's looking good. I want a title to appear when the program first starts. Use echo to print questionnaire before anything else is printed. All right, so I want a title to appear. All right, so up here, we need to put echo tilde tilde questionnaire tilde tilde. See if that works. Yes, it does. Okay, cool. Run the script and enter values until it is done again so you can see what the title looks like. All right, what's your name? Landon, Fargo. Beautiful. It would be nice to see if there was some empty lines around the title. You've probably used the dash dash help flag before. See if you can use it with echo to try and find a way to add empty lines. Okay. Echo dash dash help. Okay. That didn't work as I hoped. Another way to find information about a command is with man. It stands for manual, and you can use it like this, man command. See if there's a manual for echo. Man echo? Is that what they want? Okay, I have to go all the way down. Q for end. Okay, there we go. At the top of the menu, the -E option looks promising, and the \n below it says new line. You should take a look at those. In your script, change the title to echo here to see if that prints the empty lines. All right, let's copy this and paste it here. And then that's good. And then you can press Control C to close the program after it starts. Okay, we're going to see if it worked. Control C. All right, that did not work. Echo will only print empty lines if the value is enclosed in quotes. Place double quotes around the title that gets printed to see if it works. All right, so we just have to put quotes around here, like so, and run it. And looks like it worked, yeah. Sweet. Now it's working. Create a question 3 variable next to the other two. Set its value to what's your favorite coding websites. All right, question 3 underneath this one. Question 3 equals this. Beautiful. Use echo to print the third question after you read the location. All right. So let's echo this question, $, question 3. Wonderful. After the question you just printed, add code to read input into a variable named website. Read website. Website. I think that has to be all caps actually. There we go. Change the echo command of the response to print this sentence instead. Hello name from location. I learned that your favorite coding website is website. All right, let's just copy this. And we need to echo that. Echo, paste, hello, $name, $location, location, and then website, $website. That should be good. Run the script and enter the values on the program is waiting. Let's see the final outputs. Right, Landon from Fargo. What's your favorite coding website? FreeCodeCamp. They totally set that up. All right. One last thing. Change that final response to print an empty line at the beginning of the sentence. Change the final to print an empty line at the beginning. All right, so let's put this in quotes. And then print an empty line. So \n. Do we have to go -E? Let's see if that works. Okay, it does. Awesome. Run it one last time and enter values. See how it looks. I'm guessing it's not going to look the same. Landon, Fargo, free, FCC. There we go. Oh, it does actually work. Cool. It looks good. I think you are done with that script for now. The next program will be a countdown timer. Use the touch command to create a new file named countdown.sh. Right? Touch countdown.sh. Wonderful. Give your file executable permissions. How do we do that again? It's like chmod plus x, and then do we do countdown.sh? Okay, it does. Okay. You want to use the bash interpret again, use the shebang. So let's open up this countdown file. Let's copy this thing over. All right, see if that works. It does. Awesome. Let's close this again. Comments in Bash look like this. Hashtag comments. Add a comment below the shebang that says this. All right. So people know what it does. All right. Count down. Hashtag based. Wonderful. Programs can take arguments. You can access them a few different ways with $. Add echo $* in your script. Print all the arguments passed to it. Okay. Execute your script. /countdown ish. There's nothing. Nothing was printed. Run your script again, but this time add 3 arguments to the command, arg1, arg2, and arg3. Place them after the command with a space before each one. All right, arg1, arg2, arg3. Yeah, that's pretty cool. $* printed all the arguments passed to your script. To access any one of them, use $number. arg2 could have been accessed with $2. Change your script to echo the first argument instead of all the arguments. All right, so $1, $1. Okay, cool. Run your file with this again, and it just shows arg1. Okay, now it just prints the first argument. Your program will accept an argument to count down from. You will test it with an if statement to make sure it's a positive integer. I wonder what the syntax would look like. Type help in the terminal to see if you can find anything. Help. Cool. This is a list of built-in commands. You should look over it. Some of them may look familiar. I see echo in there. Another one is if. See if you can find out more about it by checking its man page. Man if? No manual entry for if. I guess there isn't a man page for it. At the top of the help screen, I noticed you can use help command to find out more. Yet another way to find out about a command. See if you can find out more about if with that method. Help if. It seems like it works, okay. The syntax is at the top, not all of it is required. Here's another example. Okay, if condition then statements, fi. Okay, that's weird. Remove the echo $1 in your script and add an if condition that checks if $1 equals arg1. It's in its then area. Use echo to print true to the screen. There must be spaces on the inside of the brackets and around the equal signs. All right, let's copy this. And let's go to the countdown, remove echo 1. And then we're going to say if $1 equals arg1, then go true. Go true. I think that's what they want. Yes, it is. Okay. Notice that the end of the syntax is fi if backwards. It should print true if you pass arg1 to your script now. Run the script with arg1 as the only argument. All right. Let's just pass in arg1, and it is true. Cool. The if condition worked. It printed true. Run it again with anything except arg1 as the first argument. All right, arg2, and nothing prints. All right, nothing was printed. One of the optional parts of if was an else area. You can use it like this, else, okay, and then statements. Add an else to your if, use echo to print false. All right, use echo to print false. Okay, echo false. And might have to tab that over. Let's see if that works. It is. Run the script again and use anything except arg1. All right, it is false. Sweet. Now it printed false. The program is expecting an integer to count down from as its argument. You can compare integers inside the brackets of your if with -eq equal -ne -lt -le -gt -ge. Change your if condition to check if your first argument is less than 5. Change it to see if your first argument is less than 5. All right, so if $1 is dash less than 5, arg1, which is 5. Wait, what? I am not doing this right. Um, program is expecting an integer. Okay, less than $1 is less than 5. Oh, there we go. Sweet. Run the script again and use 4 as the first argument to make sure it's working. All right, 4. That is true. That is less than 5. It printed true. Run it again with 5 as the argument. That is false because it is equal. Take a look at the help menu again. See if how these expressions work. Near the top left, it says expression. Somewhere. Oh man. Yeah, expression up here, right here. Okay. Local option. That's kind of cryptic. All right. Those look like the double brackets you are using. See if you can get more info about that with the help command like you did with help if. All right. So help expression. All right. There we go. It might not be a bad idea to read that. All right. Yeah, it's kind of long. So execute conditional command returns a status of 0 or 1 depending on the evaluation of the conditional expression. Expressions are composed of the same primaries used by the test built-in and may be combined using the following operators. All right, we can use and, we can use the shebang to make anything true, false. It's just like a regular programming language, it looks like. All right. Is 0 or 1 depending on the value of expression. All right. There's also equal and not equal operators for an individual expression. It says something about the test built-in command. See if you can bring up the help menu for that. All right, help test. That's what I was looking for. At the top are some file operators. There's some string and other operators as well. You should take a look at them. Near the bottom are the arithmetic operators you used with your if condition. Change the condition in your script to check if the first argument is less than or equal to 5. Less than or equal to 5. Change the condition. Is less than or equal to 5. Less than or equal to? Um, less than or equal to. How do I do that? Um, can I just do less than or equal to? I can just do this, right? No. Dash LTGENE LE dash LE. Okay. Oops. And there we go. They knew I would forget. Run the script and use 5 as first argument again. All right. And that's true now. All right, remember I said any command can run in the terminal or a script. Try running an expression right in the terminal by entering, okay, 4-LE5. Close that off. Oop, here we go. And nothing printed. Nothing happened. Each command has an exit status and can be accessed with $? View the exit status of the last command with echo $? And that was 0. The exit status of 0 means it was true. 4 is indeed less or equal to 5. Try it again with 4 greater than 5. All right, 4 dash greater than or equal to 5. That will be false, so it will have an exit status of 1. Yeah, sweet. It printed 1 this time for false. You can separate commands on a single line with the semicolon. Enter your last 2 commands on one line like this. It will run the expression, then print the exit status of it since it was the last command. All right, let's do that. Echo $? There we go. It's still false using the same syntax of check if 10 is not equal to 5 and print this exit status. All right, check if 10 is not equal to 5. 10-NE5. Yep, okay, you can think of an exit status of 0 as true, but it means that the command has 0 errors. All commands have an exit status. Using the same syntax, enter bad command and check its exit status. Bad command. All right, and then we can check its exit status. 127. What? Wait, what? Enter bad command and check it on a single line. Oh, on a single line. Bad command. Echo $1 or $? You should enter the suggested command. Um, hmm. Let's try resetting this quick. We'll replace it with tutorial standard progress. Your code may look different after resetting. I think I did this right though, so I think I might have to reset. Echo $, question mark. That's right, right? Yeah. Add command. Command. Oh, there we go. That works. Somehow. Okay. Command not found with an exit status of 127. Anything but 0 means there was an error with command. Bad command didn't exist. Try it again with ls. Alright, ls echo $, question mark. Whoops. Space there. There we go. The command executed as expected and there were 0 errors, so it gave you an exit status of 0. Try it again with ls-y, -y, echo $, question mark. Invalid option y. The Y flag doesn't work with ls, so it gave you an exit status other than 0, meaning that the command was unsuccessful. View the help menu of the test command again. I want to see what else is in that list. Help, test, okay. You tried a few of the arithmetic operators. Those work for integers. Try one of the file operators. The first one on the list checks if a file exists. Type this into the terminal to see if your file exists. Okay. -a countdown. .sh echo $, question mark 0. It does. The file must exist. It's checking the folder the command is entered from. Try it again with badfile.txt. All right. Change this to badfile.txt. And there's a error. I think you're getting the hang of this. Using the same syntax, check if you have permissions to execute your countdown.sh file. You may want to look at the menu again. Okay. Yeah, might have to look at the menu. How do I check that? Check if a file has executable permissions. Is executable by you -x. All right, so we want to do this with the countdown.sh file, and we just have to do -x here. There we go. Cool. You played around with a number of the expressions. View the help expression menu again that you looked at before to see a few more options. All right, help, and we can just do that for short. Looks like. As I mentioned before, you can test multiple expressions with and, or enter in the terminal to test the file is executable by you and 5 is less than or equal to 4. Okay. So -x count down .sh and 5 is less than 4, less than or equal to 4. Echo $, question mark. Beautiful. Both conditions weren't true, so the exit status was 1 for false. Try testing the same two conditions with the OR operator. Yep, so then it will be true, because one of them is true. Yep, one of the conditions was true, so it printed 0. I think that's enough of a detour. Back in your script, change the if condition to check if the first argument is greater than 0, so you can be sure it's something you can count down from. All right, make sure this is greater than 0, greater than 0. Should be good. Cool. The condition you added checks if a positive integer was passed as an argument to the script and executes the then area. Change the existing echo command to print include a positive integer as the first arguments. Change the existing, okay, if a positive integer is not used. So this has to be in the else block, doesn't it? I think this goes in the else block. If it's false, should be, yeah, okay. Run your script and use 1 as the first argument to make sure it's working. /countdown sh, and then use 1. Sweet. Run it again and use anything but a positive integer, -1. include a positive integer. Looks like your if statement is working. Next, you want to loop over the argument and count down to 0 from it. Check the help menu to see if there's any commands for this. Okay, help. There's 2 for loops in there. You want the second one. Here's an example. For, do, echo. Okay, done. The above creates a variable I equals 10, then prints it, subtracts 1, and repeats until I is not greater than 0. Yep, so this is just a standard for loop, looks like. Place the echo with a for loop that prints from the argument $1 to 1. All right, so let's just copy this. It'll make it easier. And let's replace this. Goes from when to where? I gotta see this. Let's see here. Place the echo with a for loop that prints from the argument $1 to 1. $1 to 1. So $. How do I do this? So it prints 10 through 1. In the then area of your condition, replace the echo with a for loop that prints. Okay, $1. So just instead of 10 there, we want $1. All right. And $I is this I variable. Okay. And that looks like it worked. Run your script and use 10 as the first arguments. All right. Use 10. And there we go. It prints out 10. It works, but I want it to pause for 1 second between each number. Check the help menu again. See if there's anything in there. All right. I'm not seeing the command I was hoping to. These are the built-in commands. Where are the rest? Type ls / to look around. The slash listed what's in the root of the file system. I see bin folder. Bin stands for binary. View what's in it with ls-bin /bin. Yeah. Holy crap. Lots of stuff. These are some non-built-in commands. There's quite a few that should look familiar. One is bash. That's the one you use for the shebang in your scripts. I see one called sleep. View the manual of it. All right, so man sleep. Okay. Okay, so yeah, we have to sleep I have to quit here. There we go. At the top, it says you can pause execution for a number of seconds. Try it out by entering sleep 3 in the terminal. Sleep 3. It'll take 3 seconds and then it will let me print again. Okay, cool. That should work. In your for loop, use sleep to make the script pause for 1 second after each number is printed. All right, so let's, after each number is printed. So let's go sleep 1. That should work. Run the script and use 3 as the first arguments. Let's find that. Use 3. There we go. 3, 2, 1. Done. Sweet. Awesome, except it should print 0 instead of stopping at 1. Change the condition in your for loop so that it checks for I is greater than or equal to 0. Greater than or equal to 0. There we go. That should work. Yep. Run your script with 3 as argument again. 3, 2, 1, 0. Hey, there we go. Excellent. I want it to display a title like the other script. Make it so that it prints countdown timer before anything else. Include a new line before and after like you did on the other title. All right, let's just copy this over here. Let's put it up here. And it should print out countdown timer. Countdown timer. Countdown timer. I forgot. This has to be lowercase. Come on, baby. Yeah, there we go. Run your script and use 1 as the first argument again to see the title. Okay, cool. This is fun. You can create a multi-line comment like this. Right? We use colon and then a quote. Comment out your for loop with a multi-line comment. I want to try and do this with a while loop. All right, let's comment this for loop out. Colon, that, and then end it here. Cool. And now we're going to try using a while loop. View the help menu for the while command to see if you can find anything. Help while See if we can find anything. It shows the syntax first below your comments. Not really. Create a variable named I that is set to the value of your first argument. It will start there. Then on each iteration of the while loop, you can subtract 1 from it until it reaches 0. All right. So we need $sign. No, I equals $1. Like that. Okay, cool. The menu showed that you can make a while loop like this. Yep. And let's add a while loop below the I variable you made. The condition should be I greater than 0, and you should echo the I variable in the do statements. All right. So condition I dash greater than or equal to 0, and then echo $I like that. That should work. Um, Echo the I variable. Yeah. Dash GE0. I think I did that right. It's just not running. I gotta run it. Nope. We should loop added correctly. Oh, what do I do here? I GE0 $I. That's the problem. There we go. I never changes here, so you would have an infinite loop. You can subtract 1 from I with double parentheses and the dash dash operator. In your while loop, add I dash dash after you echo $I to subtract 1. All right, let's copy that and let's just put it in here. And should it be $sign? No. Okay. The last thing to do is to add the sleep again. In your while loop, add the code to make it sleep for 1 second. All right. So let's go sleep 1. Should be good. Sweet. Run the script and use 5 as the first argument. All right. 5, 4, 3, 2, 1, 0. So much fun. I think the countdown timer's finished. Feel free to try it with some other arguments. The next one is a bingo number generator. Use touch to create bingo.sh in the same folder as the others. Touch, oops, touch, bingo.sh. Give your file executable permissions like you did the other two. Chmod plus x bingo.sh. Okay. Add a shebang at the top of your new script. All right, let's copy this. Let's open up the file and paste. Let's move this over. All right. Let's close this again. Add a comment below the shebang. Add a comment below the shebang that says bingo number generator. All right. Copy that. Copy that, Captain. Okay. Before I forget, use a single echo command to print a title for this program. It should say bingo number generator with an empty line before and after it. All right, let's copy this. And copy this. Bingo number generator. Should work. Sweet. In your script, create a number variable that equals 5. Number equals 5. Below your new variable, use echo to print it to the screen. Echo $number. Run the script by executing it. All right, so ./bingo.sh. There we go. The numbers in bingo go up to 75. Each number has a letter from the word bingo associated with it. You will need to randomly generate a number between 1 and 75. Bash may have something that can help you here. A shell comes with environment variables. View them by entering print env in the terminal. Print env. Cool. These are all environment variables. They are predefined and loaded with each shell. Most of them aren't very relevant, but it's nice to know they're there. One of them is lang. Use echo to print it to the terminal. Echo lang. There it is. Wait, right? Echo $lang. Oh, there we go. View all variables in the shell with declare-p. Declare-p. Okay, cool. This list includes all the environment variables and any others that may have been created in the current shell. There's one named random. Use echo to print it in the terminal. Echo $random. Okay, that must be a random number generator. Back in your script, use the random variable to set number to a random number instead of 5. All right, $random. Cool. Run the script a few times in a row to make sure it's working, so it'll probably be different each time. That's my guess. Yeah. The random number, or the random variable will generate a random number between 0 and 32,767. That is oddly specific. You can use the modulus operator to make it in the range you want. In your script, change the number variable to $random %75. Interesting. So that's how you can contain it to be around 75. It's pretty cool. Wait, no. Run the script again. No. Bash sees everything as a string, so it just printed the %75 part literally. In the terminal, create an I variable equal to 0, so you can play with it and figure out how to do some calculations. Create an I variable equal to 0 in the terminal. Okay, I can do I equals 0. In the terminal, use echo to print your new variable. $I. Yep, I noticed that you use double parentheses in the while loop of your countdown timer to subtract 1 from I. Type in the terminal to see if anything happens. All right. I plus plus. There. Okay, now echo again. Echo $I. And now it's 1. Okay, cool. That does work. The double parentheses perform the calculation. Change the value of I from 0 to 1. Enter help let in the terminal to see the operators you can use with the double parentheses. Oh, yeah, just do help let. Okay. You use several of these now, including in the for loop from the countdown timer. Enter in the terminal to increment I by 10. Note that you don't need to prepend variables with $sign inside these parentheses. Yeah. I plus equals 10. Cool. Use echo to print your I variable again. Echo $I. There it is. It should have printed 11 for the value of I. Using the double parentheses like you have been is good for changing variable values or making comparisons. It makes the calculation in place and provides no output. If you want to make a calculation and do something with the result, add a $sign in front of this. Okay, type $I plus 4 in the terminal to see what happens. $I plus 4 and command not found. Awesome. It should say bash 15 command not found and replace the command with the result of the calculation, effectively trying to run 15 as a command. Enter the same command. Put echo in front of it. All right. All right, let's do this, and then let's put echo in front of here. There we go. Now we get 15. Again, it replaced the calculation with the result. So it was basically the same as if you entered echo 15. Use echo to print I to the screen again. Echo I. Echo $I. Now it's 11. It should still have printed 11 for I. See the hints if it didn't. These double parentheses with the $sign are how you can assign a variable to some calculation. In the terminal, create a J variable and use the $sign parentheses syntax to set its value to I minus 6. All right. In the terminal, create a J variable. All right, J equals 0. And then use that to set this syntax to set its value. Oh, whoops. J equals $, let's see, I minus 6. Let's see. Okay, there we go. Use echo to print J, echo $J. J should be equal to 5. For some practice, use echo to print the value J times 5 plus 25. Echo $, parentheses, J times 5 plus 25. There we go, 50. It should have printed 50. Print J with echo again. It should stay the same. Echo $J, which is 5, yeah. So as a reminder, we'll perform a calculation or operation and output nothing. $, will replace the calculation with the result of it. You made a few variables in the shell. View them with declare-p. Declare-p. Yeah. Declare can be used to create variables, but you are just going to use it to view them for now. If you scroll up a little, you should find your I and j variables in there. View j with declare-pj. All right, declare-p j. J equals 5. I saw random in that list too. View it with declare-p variable like you did for j. Declare-p random 7381. Okay, I think I finally know how to get the random number for the bingo number generator. Use echo and random %75 to print a random number in the terminal. Echo random %75. No. Okay, so I think I have to go echo $, parentheses, random %75. I think that will work. Let's see. There we go, 48. Oh, we're doing the modulus operator. That's what it is, yep. One tiny problem. That calculation will give a number between 0 and 74. Enter the same command in the terminal, but add 1 to the calculation to get a random number between 1 and 75. All right, so let's just plus 1 here. No. Plus 1 inside of it. Plus 1. 48. Okay, cool. Back in your bingo.sh script, change the number variable so that it starts at a random number between 1 and 75 using the syntax we've been practicing. All right, so we need to use this $ parentheses, random %75, parentheses, plus 1 inside of here as well. All right, that should work. Yep. Run your script a few times in a row to make sure it's working. /bingo. Times, there we go, 9 and 26. Next, create a text variable and set the value to the next number is. All right, so let's copy that. Let's go here and text variable. All right, text equals paste. The letter that goes with the random number depends on what the number is. So if it's 15 or less, it will be a B. I saw some comparisons in the help let menu. Take a look at it again. All right, help let. You use the double square brackets with your if statements in the last program, but you can use the double parentheses with these operators as well. In your script, create an if statement that uses double parentheses for the condition. Check if the number variable is less than or equal to 15. If it is, use your two variables to print the next number is B number. Okay. Let's copy this first of all, if I can. My mouse is messing with me. All right. So we have to go echo this. The next number is B, $number. And then we need check if the variable is less than or equal to 15. What does countdown say? If, then. So can we do that? If, then, do, if, then, else. Let's try this. If, then, fi. Check if the number variable is less than or equal to 15 using these parentheses thing. Okay, so parentheses. Check if number is less than or equal to 15. Then print this out. I think that's what they want. Run. Your script should have the suggested if statement added correctly. Okay, get rid of this $sign. Text speed, sign number. No quotes around this. Oh my god, you gotta be kidding me. Alright, so the problem was I just need to get rid of the quotes around here and get rid of this $sign in front of the number. And now it works. And I used a bunch of hints. Alright. Let's move on, I guess. If statements can have an else if area like this, elif condition. Using double square brackets this time, add an elif condition that checks if the number variable is less than or equal to 30. If it is, use your two variables again to print if the next number is this. Alright, elif. Alright, then elif then, okay. Underneath here, let's go elif. Then, and then inside of here we have to do square brackets. And we're gonna go if $sign number is dash greater or less than 30, I think. And then we're gonna do this echo thing again. Echo, except it's going to be n. No, I. It'll be I this time. Hey, that worked. First try. Let's go. You can add as many elif sections to an if statement as you want. Add another elif below the last one, and then do n. Make sure it's less than 46. Make sure it's less than 46. All right. And let's bring this down. Make sure it's less than 46. Just less than, so LT. And then we'll do this echo thing. And we'll also have a then in here. There we go. That should work. No? elif. Come on. Elif, man. Elif number less than 46. Next number is n. That's what I forgot. N. There, wait, what? Come on. LE45. Is that what you want? No. Breh. Use double parentheses. Use double parentheses, bro. What are you doing? Number less than 46. There we go. Run your script if you want to see the output. If it should print one of the sentences if the number is less than 46. All right, it might take a couple of tries. All right, yep, it does. Add another elif below this one. Make sure it's less than 61. Use double square brackets. All right, let's just copy this whole portion down. Let's use double square brackets this time. Make sure it's less than dash LE 61. 61 LT actually. And this one should be G. Yeah, there we go. Beautiful. One more case to handle, else at the bottom. They use your two variables to print the next number is O. Yep. All right, so we just need an else block, then an echo for O. There we go. What? How's that not right? I don't need a then. Is that why? Yeah, there we go. Run your script a few times and make sure it's working. G56. I think the generator is done. The next project is a fortune teller. Use the touch command to create fortune.sh in the same folder as the other scripts. All right, let's do that. Touch fortune.sh. There we go. Give your file executable permissions. Chmod plus x fortune. There we go. Add a shebang at the top of the file. Let's open up this fortune thing. Add the shebang. Copy, paste. Should work. Yep. Add a comment program to tell person fortune. Hashtag paste. Wonderful. Add a title for this one like the others. This one should say fortune teller. Don't forget the empty line before and after it. All right, let's grab one of these. Yeah. This one should say fortune teller. Fortune teller. Oh my gosh. There we go. Run the file once. // fortune. There we go. This program will have an array of responses. One will be printed randomly after a user inputs a question. Practice first in the terminal. Create an array like this. All right. R equals a. Oh, just put spaces between these things. Looks like. Beautiful. Each variable in the array is like any other variable, just combined into a single variable. In the terminal, print the second item in the array with echo $array1. All right, echo $array square bracket 1, and that off, B. All right. If you recall, you were able to print all the arguments to your countdown.sh script with echo $star, echo $at would have worked as well. Similarly, you can use the star or at to print your whole array. In the terminal, use echo to print all the items in your array. Okay, echo wait no, R star? I don't know what you mean. Get a hint. Echo, okay, that's what they want. Oops. Echo, $R at, and that off. There we go, ABC. Variable must be in that declare list. View your array variable using the declare command and the p flag. Declare -p array. There it is. The -a next to it stands for array. In your script, create an array named responses. Give it these 6 values. Yes, no, maybe, I look good. Don't count on it. Ask again later. All right. Wonderful. Fortune. Let's create this array. Array equals, wait, how do I create this again? Let's see here. Array equals parentheses. Except I have to name it something else. Responses. Responses equals parentheses. Paste. Yes, no, maybe. All right. All right, that should be good. Sweet. In your script, use echo to print the last item in your array. Okay. In your script, use echo to print the last item. Echo $, our responses. And then we have to grab the last item, which would be 1, 2, 3, 4, 5, 6. So for number 5. And end that off. I think that's what they want. Yep, sweet. Run it to see the output. Run it. Come on, fortune. There it is. Ask again later. You will randomly print one of the values. In your script, create a variable named n. Set it equal to a random number between 0 and 5, the first and last index of the array. Create a variable named n. All right. N equals random. I have to do the modulus operator of 5. Yeah, so I have to go $, parentheses, uh, random, modulus 5, end this off like so. Does that work? Set it equal to a random number between 0 and 5, the first and last index of the array. I thought that was right. Yeah. N equals that. Run. Get a hint. Operator in 6. 6? There we go. Change your echo command to print the item in your array whose index is the random number you generated. Okay, so instead of 5, we're going to use $n. There we go. You will create a function to generate an answer. Create the help menu to see if you can find anything. Help. See any that might help. There's one that says function. See if you can find more about that. Help function. It looks like you can create a function like this, function name statements. Add an empty function named getFortune to your script. Make sure the response you are printing is the last thing in the script. All right, getFortune. Make sure the response you're printing is last thing in the script. Okay, so function get, what does it have to be? GetFortune. GetFortune. And then braces. So looks like a regular JavaScript function. And then it has statements in there, but I think we should be good. What do I have to add to it? Oh, has to be no spaces in there. Add this to your script. Let's try moving this down. Does that work? No. GetFortune. GetFortune. Function. Function name. No function. Just GetFortune. There we go. Beautiful. In your function, use echo to print ask a yes or no question. Use echo to print that. Come on. Oh, in my function. All right, there we go. Call your function by putting the name of it below where you create it. No $sign needed. Make sure the response you're printing is at the bottom of the file. All right, so we call it by just doing getFortune. Like that. Yeah, there we go. Run your script to make sure it's working. Seems like it. All right, in your function, after you print the sentence, use read to get user input into a variable named question. Use read and question. So read question. There we go. How far are we? 79% done. Almost there. Run the script again to test it out. Enter a question when it asks. All right. Am I awesome? Outlook good. Yeah, I guess I am. There we go. I want to make sure the input is a question. You are going to add a loop that asks for input until the input ends with a question mark. View the help menu to see if you can find an appropriate loop. Help. All right, to view more about the until command, help until. The until loop is very similar to the while loop you used. It will execute the loop until a condition is met. Here's an example. Add an until loop below your function. Use the double brackets to check if question is equal to test question mark. Move the getFortune function call to the statements area of the loop. All right. Yep. So let's just do that. Let's copy this. Let's go in here, and it's kind of hard to read, but we have this getFortune function here, and it has to be where the statement is, and then the condition is question equal to test question mark. Question equal to test equal to test question mark. I think that's what they want. No. Move the get function call out area of the loop. Tell you input test question mark as a question. I thought this was how you checked with equal sign. Do I have to do dash E, EQ? Is that why? No. How do I do the equal thing? Give me a hint. Use the equal. $sign question. Whoops. I forgot the dollar signs. The $sign, man. There we go. Run the script and enter something other than test, question mark, then enter test. All right. All right, something other than that, and then test. There we go, that'll look good. View the help expression menu again. You need to find out how to test if the input ends with a question mark. Help. All right, let's play with these again. You can test if two strings are the same with equals. In the terminal, use the echo syntax you used before to test if hello is equal to hello. All right. Hello equal to hello. Echo $sign question mark. Exit status of 0, it was true. Using the same syntax, test if hello is equal to world. This is so much fun. False, an important operator in the menu is equals tilde. It allows for pattern matching. Use the same syntax but with this operator. Check if hello contains the pattern L. It should, right? El niño. El niño. This has to be equals. There we go. True, the condition was checking for L within the word hello. Using the same syntax, check if hello world contains a pattern low or hello or hello world. You will need to put them both in quotes. It would help if I read all the directions first, wouldn't it? There we go. Your patterns have been checking for literal matches, L and low or. You can use regular expression characters as well, but you can't put the pattern in quotes when you do. Using the same syntax, check if hello world starts with an H by using the H as the pattern. Hello world starts with an H. All right, so let's do that. Caret H. There we go. Cool. Do it again, but use that as the pattern to see if the string starts with an H. Has at least one character after it and ends with D. Dot plus the $sign. Awesome. In the terminal, create a variable named var that equals hello world. Var hello. Var equals hello. Has to be in quotes, right? Hello world. Okay. Use echo to print the variable you just created. Echo $sign var. Using syntax, check if your variable is equal to hello world. All right, so we have to go $sign var equal to hello world, and then echo $sign question mark. No errors. Using the same syntax, check if your variable ends with question mark by using the pattern. Check if the variable ends with a question mark. So backslash question mark dollar sign. What? Check. I don't get it. What am I not doing wrong here? Oh, that's what. I have to use the equal tilde. Equal tilde. There we go. It doesn't end with question mark. Just to make sure I don't have the pattern wrong, check if test ends with question mark. Okay. Test question mark. Okay, that one no has no errors. I think that will work. Back in your script, change the until condition to see if the variable ends with question mark. All right. See if this ends with question mark by doing this tilde thing, and then backslash question mark dollar sign. Yeah, beautiful. Run the script and input something that doesn't end with question mark the first time, then something that does the second. All right, so let's run the script. Slash fortune. Ask a yes or no question. Test. And then test question mark. Ask again later. I know that it asks the same thing if the input isn't what you want. You should let users know that it needs to end with question mark. Add an if condition in your function that checks if and that, and then put the existing echo statement in the then area and make sure the existing read is below the whole if statement. Okay. Make sure the existing read is below this if statement. If this inside my function, in your function, yeah, put the existing echo, then area. Okay, then if I, inside the then area, we have to echo. Oh, here we go. Echo. You can pass arguments to functions like you did with your script. This condition will check if one isn't passed and print the sentence. Add an else to your if. Use echo to print try again. Make sure it ends with a question mark if the condition fails. Okay, add an else to your if. Else. Echo this. Cool. Now your function will print one thing if you pass it any argument, and something else if not. In the until loop, add again as an argument to where you call the function. Add again as an argument to where we call the function. In the until loop, add again as an argument to where you call the function. I need a hint. Function name, oh yeah. What should be called? Whoops. Again. Okay, cool. Now each time the function is called in the until loop, it will pass again as an argument and print the try again sentence. Before your until loop, call the function without an argument, so the first time it runs, it prints the initial sentence. I think I did something wrong. I'm going to reset quick. Yeah, go ask a yes or no question. And you have this again thing here. All right, it will pass again as an argument and print try again sentence. Before your until loop, call the function without an argument, so the first time it runs, it prints the initial sentence. All right, so let's just call get fortune right here. Okay, cool. Run the script and enter something without a question mark. When it asks the first time, use a question mark the second time. All right, test. Try again, make sure it ends with a question mark. Am I cool? No. No, why? 90% complete? Okay, awesome. One last thing, add an empty line in front of where you print the response. In front of where I print the response. In front of where I print the response. So add an empty line here. backslash n. Dash E. There we go. Run the script one more time to see if you like the output. Am I cool? Ask again later. Excellent. One last program to make. Use touch to create a new file named file5.sh in the same folder as the others. Touch 5.sh. Give your file executable permissions. Chmod plus x 5.sh. There we go. Add a shebang. All right, let's open that up. 5. Grab this. Bin bash. Copy. Paste. Go over. Continue. Add a comment. Program to run after my other 4. All right. Hashtag paste. There we go. This program will run all the programs you made so far consecutively. Add the command to run the questionnaire.sh file. How do I do that? Is it just /questionnaire.sh? Or do I have to run bash? No, I don't. Run the file to see if it works. Enter input when it asks. All right, /5. What's your name? Landon. Fargo FCC. There we go. Add commands to run the rest of your scripts in the file. They should be in this order. Questionnaire, countdown, bingo, fortune. Don't forget that your countdown.sh file needs an argument, so put a 3 next to it. All right. Sweet. Almost done. Countdown.sh needs a 3 next to it. /bingo sh./fortune.sh. Sweet. Great. Okay, use clear to empty out what's in the terminal before the big moment. Ooh, exciting stuff. All right, run the script and enter input when it asks. /5. What's your name? Landon. Where are you from? Fargo. FCC. All right, countdown timer. The next number is G52. Fortune teller, ask a yes or no question. Am I the greatest? Greatest. Outlook good. Cool, I think all the scripts are done. View the help menu again. I want to explore one more thing. View more about the type command. Help type. It says you can view the type of a command with type command. Just for fun, let's take a look at the type of a few different commands. View the type of echo. Type echo. Echo is a shell built in. View the type of the read command. Type read. Read is a shell built in. View the type of if. Type if. If is a shell keyword. View the type of then. Type then. Then is a shell keyword. Those were all from the help menu and described as a shell built-in or shell keyword. View the type of bash. Type bash. Bash is a hashed, or bash is hashed. That's the location of the bash command. View the type of PSQL. PSQL. PSQL is user bin PSQL. Okay. It's showing the location of the commands. View the type of your ./5.sh. Type ./5.sh. 5 is 5.sh. Last step, close the terminal with the X command. Thanks and happy coding. Exit. Let's go! That took so long, but I learned so much. Fantastic. All right, let's go to FreeCodeCamp. See what it says. Relational databases. Did I complete it? I did. Build 5 programs. Check mark. Yippee! All right. If you like the video, make sure to give the video a like, comment down below if you have any questions, subscribe if you haven't already, and I will see you next time. See ya. Peace out.